Hi, my name is Emma Vierheller, and in 3 minutes or less, I want to talk to you a little bit about how I'm using Desmos to help my students understand circle similarity and specifically how to prove that all circles are similar to each other. So, here's an opening activity my students go through. I want my students to understand or to check if they know what it means for two figures to be similar. They often think that congruence and similarity is the same thing, so we're going to work through that. Then, my students are going to compare and contrast a couple of circles. They're going to make the connection that one way to think about similarity is through the transformation of a dilation. And they're going to translate and dilate a couple of circles so that one circle lands perfectly on the other. They're going to end this warm-up activity with answering the question, do you think that all circles are similar to each other? Why or why not? So, there's an open activity. This last screen is going to lead to some discussion. I love when I get Chromebooks out and my class is louder than normal. That's usually the opposite of when we put our students in front of computers, but it's really exciting to feel the buzz and the energy in the classroom when we get to discuss something like that. So after we've had this discussion, I would pull up this graph that I've created. It's just two circles where you can change the radius and you can change the center of both of those circles. So what I would want my students to do is explain to me how would you have to move the green circle so that it lands perfectly on top of the purple circle. So we would talk about how we could move the center and then how we could change the radius. And we've got the ability to do all those things down here. Luckily for me, I've got a little solution down here. That way I can make sure that I'm doing my scale factors in the right direction. Nothing more embarrassing than being wrong in front of students, except for it's kind of fun when they correct you. So we would go through a couple rounds of this so that my students get the idea of, oh, well, I need to translate in this direction, then I need to dilate by this scale factor. I need to translate and then dilate, because ultimately what I want my students to be able to do is for me to give them two circles where they don't have an exact center. Instead of being at 4, 5, it's just at x1, y1. And then the second center is just at x2, y2. And I don't give them a radius that's a number, but just any radius. So that we're taking something specific and then creating a more general proof for it. What I like about these two things is that they integrate seamlessly into the classroom and the culture that I'm already creating. These activities aren't replacing me. Not that I think I'm that important, but I do think that the role of a facilitator of discussion is extremely important in making sure that our students have authentic experiences with math. These are both really easy to create, and they're supplementing my class. They're not replacing my class, and they're also driving discussion. So these are two ways that I can integrate Desmos pretty quickly and easily into the classroom that I've already created. I really like using custom activities. Graphs are easy to use. Obviously, I'm bragging about the company that I want to give me a fellowship, but I just wanted to highlight the things that I do with Desmos so you get a little bit better idea of what I'm doing. My 3 minutes is more than up, so thank you very much.